Good morning. So we are about 4 minutes into the session. So I have only one person in class here, Art, and now 2 people online. So there are probably a little bit more coming. Okay, so today what we'll do is we'll go over usability aspect of what we have been discussing. If you remember, at the beginning of the semester, on our first lecture, we discussed, or I told you about this thing that, okay, augmented reality is a user experience technology, and we should pay attention to usability of things. So as an engineer, we can, we can solve problems, right? So we discuss a lot of these problems, like how do we do rendering, how do we do, let's say, calibration, how do we track things of interest to us in 3D so that we can actually know exactly where to put our rendering. And these were more or less engineering things, right? So some mathematics, some algorithms, and some techniques that we use in other domains like graphics and computer vision. We put them together, we enable this augmentation. Augmentation in the sense that we can now augment things in the 3D, and we can enhance a user's view with 3D graphics, perhaps. It doesn't need to be 3D, but at least we can augment things in 3D, maybe with a 2D graphics or whatever. But the question is going to be, how is this going to be useful or used by let's say, a user of this system? So how is it going to help? Is it going to actually be easy to use at the end? The idea of having some augmentation in the scene, how useful is it? What is it going to solve for the user? I mean, at the end of the day, we are going to build a system, be it a head-mounted display-based system, or meaning some sort of see-through, optical see-through, and also let's say a handheld device like a tablet with a video see-through technology. What are we going to provide to the user? What problems are we going to solve for the user, right? And how much the user needs to know about things, how this technology works, how much learning curve should we go through to, let's say, for the user to make useful things out of it. And these are all valid questions to actually design a system that will help perhaps the user in some ways, maybe entertain them, maybe make their tasks easier compared to without your system, or you made them, let's say, you help them make a job, carry out a task that they could not otherwise do, right? So this could be, if it is inevitable that your system is actually, let's say, making someone do something that they could not do before, this will sell itself. But the cases where you'll have that is going to be very, very limited. So you are not going to have a system that, let's say, makes someone do something that they cannot otherwise do. Those are very, very rare cases, extremely rare. If that was the case, then we would have seen this technology, this, let's say, augmented reality technology in use today. Because if you are able to actually make someone do something that they could not do otherwise, and that's a useful task, then you will have these systems helping those people. usually in real life, there are many alternatives to doing something. Sometimes less efficient, perhaps. Sometimes even more difficult than, let's say, an alternative method. But regardless, you have, regardless of these, let's say, efficiencies, expenses, perhaps, learning difficulties, learning, let's say, curves, you still have a lot of alternatives, and people actually go for those alternatives, sometimes worse alternatives than, let's say, than better ones. And there are a lot of reasons for that. And this is some of the reasons we are going to see are going to be related to some usability aspects. So people, for example, will tend to go for what they have already. If they know something, they will be it will be very difficult for you to actually change them and adapt something else. This is reality. Some things are actually are like that. So if a new technology, if a new thing is not accepted for some reason for your population, the targeted population, then it's not going to happen. You have to then work with these people to actually overcome whatever the, let's say, the barrier is. Again, the barrier could be cultural, could be learning curve, could be, let's say, just human beings are habitual. They just build a habit and they like to keep that habit on. They don't want to change unless, let's say, maybe something drastic happens. Maybe they are forced somehow for whatever reason. But forcing someone to actually change something is going to be very, very difficult, right? So, but there are things that we can actually, people have been working on this one quite a bit, and we have seen examples of these things. For example, computers were not there from the beginning of, let's say, humanity's, let's say, human beings, let's say, life in history. It has only, let's say, 50 years or so, something like 50 years, maybe even less with some technologies. Now, people have been studying the effect of, let's say, even simple, let's say, interactions like, let's say, screens and how they are, let's say, take a laptop, for example. How would actually someone use this laptop? And how would you actually change someone from, let's say, simple desktop to laptop? Even that is a change, right? But people have been doing these type of things quite a bit, and people have been studying this. And the study, the kind of the science behind this goes with several different names, like user experience design. This is one thing. HMI, human-machine interface, is another thing. Human-computer interface is another thing. And you'll see that this is actually going to be based on a little bit of psychology, understanding, let's say, the perception of people, the targeted people, and also some, let's say, it has a science behind it. So it has, it is usually experimental. So you build something, you devise something, some strategy, and then you test that strategy over people, and you actually get some metric, and you say, okay, this seems to be better this way if you do it this way, and so forth. So what we'll do is we'll kind of touch upon those basic ideas here. As I said, the study of usability is not a very, very old thing, but still older than, let's say, what we'll see for augmented reality. So maybe it started maybe in the 80s, and it got actually quite, let's say, quite a bit of attention in the 90s, and even today, people do a lot of usability studies. And as I said, there is a reasonable science behind it.
As a matter of fact, sir, nowadays in Europe, in some universities, it's taught as a department of human-computer interaction, a whole university branch, actually.
Exactly. So there are, I mean, of course, this area is kind of, let's say, for engineers, for us, this is kind of a soft area, right? But it's a very, very important area. I mean, a proper design, usability design of a system can either make it or break it easily. I mean, this is probably, it is even more important than the technology behind. Technology is an enabler. It's not let's say, the final thing. The final thing is going to be actually, if it involves people, it's going to involve some usability design. And if the usability design is not properly done, then you'll have a problem. I mean, I think one of the examples, I'm not saying this example from a study, but at least my perception, you see that the smartphone, let's say smartphones are computers. I mean, this is what it is. It has certain capabilities, but what is the technology is computing. Now, let's say in the early days of smartphones, the best smartphone was from, do you know which one it is? Which one it was? The best smartphone? Most, let's say, used one and sought after?
iPhone?
No, before iPhone.
Was it BlackBerry?
Yes, BlackBerry. So BlackBerry was, let's say, a system that, I mean, BlackBerry is a phone with two things, I mean, a screen and a touch, let's say, a keyboard in one place, right? And these guys were very smart in actually, you see the transition before before, let's say, before the smartphones, the most mobile thing was actually a laptop. And I am of that generation that I'm still using laptop. I cannot do without a laptop. This is what we actually started from workstations to, let's say, home PCs to laptops. And mobility-wise, this was it. It was bulkier than probably what I have here, maybe heavier and so forth, but this is what we had. And in the business world, especially, this is used for all different types of, let's say, connections, especially emails and so forth. Now, BlackBerry people actually, maybe by luck, maybe by design, sometimes you cannot know which one came first, but they connected this thing because this has a screen and a keyboard in a smaller place where you can actually now at least do your emailing. And you have another additional thing that it's a phone as well. It's a mobile phone. Now, if that design probably was a very good one from the perception perspective because we are used to typing on a keyboard. Now you have a keyboard that actually it's in your hand, and you still do most of the things, or not necessarily most of the things, but some major things that you could do on a laptop, you could do this on a phone, and with some additional things. So this is a very nice transition. And when that transition went from, let's say, from those small keyboards to touch, there were quite a bit of actually resistance also. And the touch screen was there. I had touch screen phones from Samsung and some others. They were like, because of the limitation of the fingers and so forth, because we are typing it this way and our fingers are, let's say, holding an entire key when we start something and when we type something. In the case of BlackBerry now, it is a smaller thing, but we still have tactile feedback, right? So this is one of the transitions. And then from that transition to tactile feedback to now touch, people could not actually do that very easily. You need an enabling technology. First of all, you should have a little bit larger screen because your fingers will not actually fit into a small screen. And an alternative to that was a pen. So you actually have a pen, you do this one. But pen with people are very difficult. You lose them, you drop them, you actually, not everybody is, let's say, very, let's say, careful about the usage of these things. And it didn't pick up. I had one of those, and it was very good. It was better than, I think, even BlackBerry, because now you have your entire screen to do your stuff instead of half of the screen. But you have this pen, and you lose the pen. And when you lose a pen, you are in trouble because you have to find something, and it's not easy to find, and so forth. Now, the transition from that is actually if you have a larger thing, and if you manage the real estate on the screen with typing, you actually transition from, let's say, from keyboard to, let's say, mobile keyboard to now touch screen. So this is, I mean, this is not happening in a vacuum. This is happening in that transition where people, let's say, iPhone was very smart in that. iPhone inventors were quite smart in that actually they followed that transition and made things happen. And then after that, you see that actually it's now building upon that one. Similarly, we'll see that the 3D interfaces are not that easy to actually, let's say, just transition to right away. Because we don't have any, let's say, any history of it. It's not a progression. The progression is we still have 2D screens. Even if we have, let's say, mobile phones, and we are mobile, we can move anywhere, but the perception that we are getting things from is actually that mobile, that 2D screen, and with perhaps some touch and interaction capabilities, but still happening on that device. Now, if you recall your first homework, we said, okay, the entire homework was about what, let's say, some mechanisms to interact with your 3D world. First, perception-wise, what you can actually show to the user, and with the interaction-wise, you can interact with screen, but you can also interact with the 3D world as well. And that becomes a part of an interaction mechanism. But it's not an easy thing. And I saw that actually half of the class didn't even understand that second part of the interaction. Most of your homeworks didn't have interaction with the objects in 3D. I was expecting, for example, if you have this object here, and let's say you are holding your tablet or your phone to that, you can interact with this object if you are tracking it on a 2D screen. You can look at or you can press the, let's say, pixel, or choose a pixel with your hand or fingertip that corresponds to a portion of this thing, and then that is an information to you. That's an interaction mechanism that actually this allows. But also, you can go and actually touch this. And if you are able to actually track your finger somehow and this device, then you can take that into account as well. Now, my interaction is going from the screen to the 3D world. Interactions could be even as simple as, I say, moving this from in your environment. Now, this is also an interaction. When I move this in the environment, I perceive this. Therefore, this is a potential for me to actually communicate something to the computers, to the system that I'm interacting with, right? Now, but this is not a simple thing. This hasn't been done before. All the interactions were actually done on a screen with a keyboard, mouse, or touch, whatever, but still that progression goes from all things like I do something, I see that it happening in the 2D screen, and I actually got it. So the interaction goes actuate something, see that, and in a way either perceive it or let's say accept it, and then do this like loop. Now I am putting into that loop something else. I'm actually looking at the screen, and I'm looking at the actual scene as well. And actual scene is not a 2D anymore, it's 3D. So my interaction, the action space in this world changes quite a bit. I move around, this is my action space. It has 6 degrees of freedom now. And in the past, my degrees of freedom were very limited. Like a mouse, for example, I have the mouse moves on a plane, 2 degrees of freedom. And then I have clicks, maybe 2 or 3 clicks, or let's say scroll, but still very, very limited in terms of the space, the action space that I have. Now, in the world, just moving my camera, moving my position and orientation, I am inducing 6 degrees of freedom. On top of that, I am actually making my 3D world actually move as well. I'm interacting with my 3D world. Let's say occluding an object or moving an object, or let's say pressing perhaps a virtual button on the object itself. Now, all these things will increase the complexity of your interaction space. The question is, are people ready for that? Right? And this is what we'll need to actually look at. And we'll start with some simple comparisons between what happens in 2D and what happens in 3D. We are now assuming that augmented reality or virtual reality, for that matter, is similar. Augmented reality is a 3D user interface now. We are going to assume it is that way. Why it is 3D? Because, again, my action space, and the things that I'm interacting with are in 3D. Even the, let's say, perceived virtual is in 3D because they are registered. Now the question is, how is this different than 2D? Because 2D has been studied quite a bit. The 2D interfaces with let's say a mouse, keyboard, and a screen, or even touch screen, has been studied quite a bit. And these slides are from Stefan Feiner. He's at Columbia, and I took it from one of his courses in 2014, I think. So we can actually look at it from a few different perspectives. First perspective is users and tasks. How are they different and how are they similar? What is our user? Is our user any different in a 3D user interface than a 2D user interface? This is an important question, because if it is, let's say, the same, then what we need to do is we can actually use let's say, the research in a 2D interface and just apply it to 3D. At least from the population perspective. But they are not necessarily the same, because we have usually, let's say, if you are building a training system, now your users are, let's say, just, let's say, students, perhaps. But if I am building a system for, let's say, a design review. So this is one of the examples that we have. We have an example where, I think I have told you about this example, but let's talk about it again. So car manufacturing, okay? Car manufacturing has distinct steps that people go through. So the first step is the design. So this happens all in virtual. And then at some point in time, you have to actually get to a kind of it's like a physical thing. You have to have a physical thing. And what people do is they usually build clay models of the car. So they take the 3D model and then actually build a clay model of that car to see the shape. And they want to realize it in 3D when I actually get to it. How high is it? what is the curve, what is this and what is that, okay?
The real size of the car.
Yes, the full size of the car. This is what happens. I mean, this is the design stages. And then after that design stage, what they do is, of course, they work on that clay model. They change it, right? But there is the problem with working with a clay model is not moldable. Once you do it, it's there. You cannot easily add stuff to it. You can perhaps remove things, but adding stuff to it is going to be quite difficult. And clay model will only get, let's say, a certain outside shape of the thing. So, for example, you wouldn't know what the color is going to be because you cannot just paint it again and again and again. So what happens is that this augmented reality and virtual reality, people have been actually exploring, let's say, how we can improve this clay model. We start with a clay model still because it gives a physical presence. This is good. I mean, this physical presence of things is very important. You wouldn't realize it, but if I am actually putting a perfect car as a hologram here versus a car that is actually there, even if it is not perfectly representing what you have, you get a different feeling, the physical feeling when you are around that actual object versus that, let's say, virtual object, because somehow, I mean, you have senses, you sense them. I mean, your touch is one thing, even if you don't touch it. Let's say if you are moving a little bit, you create some airflow, and that airflow's interaction with your environment, actually you have this faint sense of things that actually it's there. And this is a very important thing. If that perception is a very important thing to actually try there, perhaps, let's say, designers are looking for that, then you can not replicate it. So augmented reality says, okay, maybe we have the form of the car there, but I can augment it with, for example, color. I can put a mirror there. I can put, let's say, a camera here and whatever. So this is one of the use of augmented reality. Now, you can see that your users there are not actually your regular, let's say, every time user of a, let's say, a phone, right? So these are professional people. They are probably engineers and artists and maybe designers, industrial designers, and a combination of maybe even, let's say, some, let's say, marketing people and probably your executives, right? That will make a decision on these things. Now, this type of, let's say, user and the task is going to be quite specialized. So you cannot actually just assume that you can get these, let's say, the perception of those people and the design that you are going to actually do for them for an augmented reality system is going to be different than, let's say, your regular, let's say, layman, for example, right? So this is important. So we have to actually understand if the users and the tasks are the same as 2D user interfaces, and sometimes they can be, but most of the time I think they are different. And then the second thing, we have to have some way of actually evaluating the and designing these experiences, these user interfaces. And since we are using different, let's say, we are appealing to different parts of the senses, right, in different ways, then 3D user interfaces and 2D user interfaces will have differences in them as well. So we have to be careful. We may need to use some sort of different level of heuristics to actually make it happen. We are going to talk about that in a few minutes. Of course, devices that we are going to be using is going to be different, right? Desktop to laptop to palm top to, let's say, you don't even know what a palm top means. This is kind of, let's say, in between things, between a maybe you can think of this as tablets, but a smaller tablet. It's an in-between thing between your, let's say, computer and phone. A palm laptop is a small enough device that you can carry around. It has some, let's say, capabilities of the computing device that you have, but it doesn't have a phone connection, for example. And it doesn't have perhaps also some sort of internet. This is early 2000s. So when you don't have these, let's say, common access to 3G or even Wi-Fi. Now, these you have to actually see, and we'll see that actually things are going to change here, of course. And then the fourth one that we are going to be looking at is actually the development environments for these users, for these interfaces, user interfaces, and they will have different differences as well. All right. So one of the differences that we are going to see is, as I said, there is quite a bit of, let's say, established research in 2D user interfaces, but that is lacking for 3D user interfaces. From the perspective of research, but also, let's say, things that these enabling technologies, and I think put these slides together in 2014, spring 2014, or maybe, no, actually, fall 2014. And even then, even now, we don't have, let's say, these technologies are not, there is no standards. Everybody does whatever they can find. So, for example, there is no standard in let's say, in graphics, in modeling, in tracking, in displays, in head-mounted sets. Nothing. I mean, someone has a head-mounted set. They do their own stuff. Someone has, let's say, a tablet. Tablets are not designed for these things anyway, but you try to actually put something in there, like the cameras on the tablets, the way that, let's say, the graphics on the tablets and so forth. Nothing is actually standardized. There is not even a, let's say, operating system. I mean, you can see, for example, there are a lot of designs or, let's say, standardization in 2D interfaces. And Microsoft wanted to have this, for example, this WFC, what was it, WFCD or something, WFC, Window Foundation classes, something like that. So there have been quite a bit standardization in the 2D part, but 3D is not there. There is, for 3D user interfaces, it's all individual efforts and no standardization around it. There have been some attempts. The Web 3D has some, let's say, at least addressing some of these things from modeling perspective. Kronos has this WebGL, and there is this ARstandards.org thing, but it's not actually active these days. I don't see if they're active. I haven't seen anything from them for a long time. And but you see Unity, for example, having this from the tracking and rendering perspective, they are doing this AR framework or some sort of AR foundation, so that you can actually kind of put things together easily. So it is moving, but still the standardization is not there. But the standardization is important from two perspectives. One perspective is, of course, from the developer's perspective, but also when you have these standards actually in place, this affects the usability or user experience design that you are going to actually do. And you will actually build upon those standards. And in this case, we don't have that. All right. We talk about the users and tasks. We'll come to that again. But Another part that we are going to discuss is the sensor modalities, right? So with a 2D screen, you have sight, 2D sight, and vision, and sound. These are the kind of, at least the sensory thing that you are actually gonna get. And perhaps a little bit touch. I mean, touching let's say a screen with a touch screen, or let's say touching a keyboard and touching a mouse. And maybe you have haptic devices as well. Those could actually give you some other modalities. But in 3D, this is a little bit different. Now, in 3D, the first thing that you are going to do is you are going to actually bring your, let's say, motor, your movement into the senses. So you are going to move around, and you have your balance, sense of balance is going to get in. You are going to have your sight and hearing, sound intact, but mostly 3D. So you'll be having, let's say, 2 ears instead of 1. In the other case, you will have two eyes instead of 1, and 1 would be sufficient for your 2D screen. But now you need to have 2 eyes to see the depth. And as I said, your movement is going to actually induce right away a 6 degrees of freedom motion change or interaction capability with your world, which is not there before. So, and then of course, touching an object in an extended reality type of a thing, you can move the object in the environment. You can actually, let's say, place a virtual button in the environment and so forth. So this sensory modality is going to also involve your, let's say, your kinematic. We'll call this one in a few minutes with a different name. So if I actually move my hand like this, I have a lot of different senses. My touch sense is affected, but also my, let's say, joints have some feedback to my brain. And I have that feedback actually. And when I move around also, I have that feedback, and I have to actually see how to make that feedback useful in that interaction. I cannot just ignore that, because that's a different thing. In the past, I could have been, let's say, my screen is here, I can do this way, I can do this way, I can do whatever. But from this way to this way, for my user interface, it has no impact at all. I don't know, I don't care if Alp is staying straight up and I am sitting a little bit hunched like this, or maybe someone is laying down on their couch. It doesn't matter. At the end of the day, what you design, when you design your thing, you are not designing it for how people are actually, let's say, doing right now. But in my design for a 3D interface, I have to know if you are walking, for example. Why? Because if you are walking, you are going to get tired. Right? If you are standing up, you're going to get tired. I cannot expect you to actually look at an object here and standing up like this forever, for a long amount of time. I mean, long period of time. Maybe even smaller, let's say, short period of time will be also difficult for me. So my design has to actually take that into account. If I'm forcing you to look up like this, so you are sitting here, you have a video see-through, optical see-through device, and I'm putting something there, and I'm asking you to actually just stretch your head, kind of neck like this, and look at it for 10 minutes. Impossible. So you have to take that into account when you actually do your design. Before that, I had no idea. I don't care if you are sitting, standing, you are running, you are, let's say, just laying down on your couch or whatever. I don't care. But now I know that, and I have to care about that. At least I know, I may not know what you are exactly doing, but I know that you are, let's say, standing up. And I'm looking up something like this that will actually require a certain way of actually, for me to design the experience so that it doesn't physically strain. All right. So in the interaction techniques, we'll talk about perception, of course, selection is important, manipulation, and navigation in 3D. These are important things that we have to actually look at. The devices, display devices and interaction devices, will have stereo, sound, we'll have 60 degrees of freedom, head body tracking, wearable things, this is important. If you have a glove, and it can actually force you to have, let's say, some force feedback, maybe touch, these are gonna be important as well. So in terms of evaluation criteria, we can talk about things like realism. How real should it be? Is realism important? In what aspect? In what perspective? From what perspective is it important? So, for example, if I am trying to give you a sense of, let's say, just I want you to actually realize, let's say, how big things are. This is the experience that I'm trying to give you. In that case, realism in terms of actual scale is going to be very important. But perhaps let's say the quality of rendered images or rendered video doesn't need to be that good. Maybe it needs to be good. I don't know. So you have to actually think about these things. So do you need a realism and alongside realism, presence? How are you going to actually design a presence? One of the examples that I showed you in the introduction lecture, if you recall, an experience that we wanted to have in a tank. So this is a military application, and this was in defense fair, and one of the companies actually built an entire new tank. It's a big tank. They brought it there, but I don't know. I'm not a military person, so I have no idea what's happening. But apparently, the inside of a tank is a very cramped space. It's a very small space. There are a few people there, and what they wanted to do is, this is a trade show for defense technologies, but there are two types of people coming in there. One is important people that pay for those weapons and just purchases them, and public. Public is for, of course, propaganda, right? So what you need to do though is you need to, for example, if I am a fan of tanks, I go there and I look at it. It's big, it's nice, okay, but I want to get into the tank. I want to see how it is looking inside. And since it's a cramped space, you cannot actually let people get in. So it's very difficult. So what we did is we actually designed a system, a virtual reality system, where the basic idea was, in terms of realism, it was the presence of let's say, a cramped space. So we built that thing. It was, let's say, getting the geometry right, but the quality of rendering was not exactly what inside. We didn't need that, because the idea was to focus on the kind of the cramped space. And when I first put this thing in, after design, it gave me that effect. It gave me the effect that actually I'm in a very small place, and we are actually simulating the gun being, let's say, shot, and there is a recoil, and the recoil comes this way, and it is so close. I can see it. It's so close that I put my hand out like this, and it's actually hitting my hand. I can see that. So this is kind of, let's say, the thing that I want to design. Now, evaluation-wise, you can actually look at the present aspect of this evaluation versus, let's say, realism aspect of this design, right? Immersion is another one. And the question of actually how do you, let's say, measure these things? Quality, for example, image quality can be measured somehow, but video quality perhaps, but in a see-through device, optical see-through device, How do you do this thing? And the question is, of course, is it necessary to have that big, let's say, realism? That does it need to be that realistic? Maybe you are actually looking at the presence. Maybe you are looking at the immersion. Okay, how do you measure immersion? Like this one. I want to get a feeling of cramped space. So how do I measure it? Perhaps this is one of the things. But maybe, but then when I actually start measuring it, what are you going to do? You are going to ask me? You are going to measure my, let's say, brain waves. You are going to look at my pupils, for example, perhaps, or you are going to actually put some sensors to see if I'm sweating, if my, let's say, heartbeat is actually slowing down or increasing and so forth. This is still quite difficult. And other things like this, for example, I told you about this one. Not all people can see in 3D. Some people cannot see, perceive stereo easily. Okay, and the kind of the experience that you are going to give is going to be actually defined by also your past experiences as well. If you have been in a, let's say, tank already, what are you going to think? Is it going to be the same as me? No, it's not going to be. Someone that has been in a tank for a while versus me, I have no idea what a tank looks like, maybe from the outside, maybe from movies, and I'm seeing it, and now I'm inside it. That presence, that immersion is quite different. The sense of immersion for me is quite different than, let's say, the other person that has, let's say, experience with these type of things.
My question is, in the case of the tank, how would it be like claustrophobic kind of sensation if you could move your hand around and you could actually see that you're not touching anything?
Okay, no, this is a good one.
How would it trick your brain into thinking that this is a...
We are very, very visual. Why are you getting, you are watching, let's say, a horror movie in your home, you're in your couch, and maybe with your friends or whatever, your significant other, and you are there in the comfort and safety of your home, and you are watching a movie, and it scares you. How come? Right? So if you make the design properly, you can actually give that. So first of all, our eyesight is very, very strong sensation. It can actually easily kind of suppress others like touch, and we'll call this kinesthesis. Not kinesthesis. Some, let's say, kinematic feedback, your joint feedback. It will actually kind of suppress that, because we are visual. So if you do that properly, that visual, like a horror movie, then you can actually get that effect that you want to have. But it's not going to work for everything. Again, realism could be one part of it. I said it was not realistic, but what we did is, for example, one of the good example of this one is a 3D movie. When you go to a 3D movie, and the best example is actually is Avatar. Now, what they did is they actually designed the experience in a way that it fools you all the time, and it actually also expects you to kind of think ahead and actually kind of ask for more and more and more. This is one of the things that you need to understand. Cameron, it was Cameron, right? So that guy knows what his audience is expecting, and he can actually build it. He can actually keep you watching it and actually expecting more and more and more. Similarly, in that design, of course, did we do this by, let's say, by maybe scientifically, or maybe a little bit with luck, or maybe some expectations that we had already in ourselves. But at the end, it was actually a successful one. And I have seen a lot of others that were not successful at all. And for example, I have seen one case that they actually showed me, it's in a virtual reality example as well. We are working on something like let's say a very high building, and there is an edge. And what happens is that they have a platform and they move the platform a little bit. And now your kind of, when you are walking, your feet goes to empty. You don't see your foot, okay? But you know where you are. You know where your foot is supposed to be, let's say left foot. But when I actually step in there, knowing that actually it's going to hit something, I know that because I'm in a room. But I got scared so much because I thought that I was actually just stepping into a void. And then I will actually just tumble down. But again, it's only a few seconds, I mean, maybe a fraction of a second, because then my foot hits the ground, then I realize that actually it's not the case. But if you actually do that properly, then you have your this expected outcome. So perception, perceiving things, selecting, manipulating, and realism, presence. And these are all actually, since it is actually now psychology plays a lot of role here, then you have to understand the psychology of the people, and your evaluation measurement should actually take all those parameters into account. Like, is this guy actually someone that has been in a tank before or not? Or let's say, whatever the past experience, you cannot control a lot of these things easily. So parameters are much more than in a 2D case. So you have to be very careful with this one. Of course, this simulator-induced sickness, the cyber sickness, is an important thing. You have to actually make sure that that is not there, and you nausea, yeah. So, I mean, if you let's say design so for example, I should have done this one, but so we have these examples where you have these videos, and you just put a 3D goggle, and you sit down here and watch the video. Okay, one of the videos is one of those high-speed airplanes. And they do this all sorts of things. And it starts with very simple, and then it starts rolling, and I will go mad. For example, I will certainly throw up, because this is for me, cyber sickness is very bad, and the reason is that my sense of balance and what I am seeing is not actually matching. And this is where things actually happen. So you have to actually make sure that that is not the case in your application. You can easily nauseate people. And even if you don't get this cyber sickness in that way, spending, let's say, 15 minutes in a let's say virtual reality environment is going to certainly give you a headache. So you have to control that. You have to control the amount of, let's say, strain that you are putting on that person, and so forth. All right.
Like an amplified example of the reverse and the bus.
Exactly. I mean, one of the demonstrations that Oculus had was a roller coaster.
Right.
So they sit you, first of all, they sit you in a chair, and you get on a roller coaster. It will kill me after like 5 seconds. And then if you actually make that person stand up, it's going to be even worse. Now, sitting, for example, you see that, okay, your sense of balance tells you that, okay, you're not doing something right, but you are at least sitting, and you get some perhaps safety, but also some feedback from your joints that you are not actually moving as much as, let's say, your scene is moving. So there is that level of, let's say, it compensates somehow. But when you are up, now much of your joints is kind of inclined to react to it. Now your balance and your joints are actually just fighting because your vision is actually not agreeing with what your state is. So most people actually just fell down. Okay, so let's take a 10-minute break. We'll continue.